Hello, warriors. This is Miss Lemons, and I'm coming at you now with more notes on phase diagrams, specifically the worksheet questions 7 through 10. Okay, so questions 7 through 10 actually is a little bit different than what we've been given previously on the worksheet. Instead of giving you an actual phase diagram, we've given you a table with melting points and boiling points. Now, this actually doesn't have to be difficult. So what I like to do is kind of draw a big graph where I've gone ahead and provided myself a graph, and then it's asking us for the normal melting point and the normal boiling point. That means that this has to take place at room temperature, or at, 1 atm or 101.3 kilopascals. So I went ahead and I marked where 101.3 kilopascals would be. That would be where our normal boiling point and melting points would occur. The questions 7, 8, and 9 all ask if what substances of these four would be solids, liquids, or gases at 25 degrees Celsius, which is room temperature. And I also marked on here where room temperature would hit on here. So for each one of these substances, I went ahead and I color coded them, and I'm going to kind of plot them on the graph. Now, this is not going to look like a phase diagram like I've showed you. It's going to look a little bit different because I'm plotting all four substances. So the first one, butanol, it has a boiling or a melting point at negative 89 degrees Celsius, which is about here. Okay, and its boiling point is 117.7 degrees Celsius. Okay, so when I'm looking at this, I know that the triple point, well, I know looking at this right here is going to be our boiling point, and this right here is our melting point for this substance at 1 atm of pressure, or 101.3 kilopascals of pressure. Okay, so this is our melting point, this is our boiling point. Now, I know that if I am anywhere to the left of this line, anywhere to the left of the melting point, that means I'm going to be a solid. And if I'm to the right of the boiling point or melting point, I know that I've melted from solid to liquid, so it's going to be a liquid here. And if it's a boiling point, anywhere to the right of the dotted line would be going from liquid to gas. So this would be a gas. So at room temperature, at room temperature, 1 atm, we are going to be a liquid for butanol. So we're going to do the same kind of process with ethane. Ethane's melting point, ethane's boiling point, they are the same. I just staggered them so we could see both of them. Remember, anything to the left is going to be a solid, anything in the middle is going to be a liquid, and anything to the right is going to be a gas. So at room temperature, you can see that we are far colder here. So we would be a gas. Oh, I guess that never came up. It should be a gas. There we go. And you can see that naphthalene has already been ruined, but that's okay. We can still plot it. We have a melting point at 80.26 degrees Celsius, and then a normal boiling point of 218 degrees Celsius. So remember, anything to the left is going to be solid, anything in the middle is going to be liquid, and anything to the right is going to be gas. And you can see that at room temperature, naphthalene is in fact a solid. And then finally, we have salicylic acid, a normal melting point of 158.6 degrees Celsius, a boiling point of 211 degrees Celsius. So then we've got this would be a solid to the left of the line, in the middle is the liquid, and to the right is a gas. So that would mean salicylic acid is actually solid at room temperature, or 25 degrees Celsius. The last question asks you about intermolecular forces, as far as which ones have the strongest intermolecular forces or the weakest intermolecular forces. And this is a tie back to Unit 6 or Unit 5 when we're talking intermolecular forces and molecular compounds. In this case, remember, intermolecular forces, remember, those are the attractive forces between molecules, okay? And if something has a higher boiling point or a higher melting point, it means that it is more difficult to break those intermolecular forces. So the higher the boiling or melting point, the stronger the intermolecular forces. So in this case, we have the highest boiling point is going to be between salicylic acid and naphthalene. And I would actually argue that naphthalene has the highest, because it has the highest boiling point, has the strongest intermolecular forces, because it takes a lot more energy to break it apart. And then for our lowest intermolecular forces, our weakest intermolecular forces, I would argue that ethane is a substance with the weakest intermolecular forces.